So for the first one, we want to determine if it's symmetric about the x-axis, y-axis, or origin. So if you think about being symmetric with respect to the x-axis, that would mean that y and negative y, for any x-y pair, that would mean that x negative y is also on there. So if it's symmetric about the x-axis, I need to check that if I plug in negative y for y. So to check symmetry about the x-axis, we want to plug in negative y for y and see what we get. So if we do x squared plus 2x times negative y minus negative y squared equals 4. And let's see what we get. We're going to get x squared minus 2xy minus, and when we square negative y, we get a positive y, so minus y squared equals 4. So then we compare, does this look the same as our original function? And I can see that it's not the same because this sign that was positive is now negative. So it is not symmetric about the x-axis. Okay, and for symmetry about the y-axis, it's going to be similar. If it's symmetric about the y-axis, then for every point x, y, there would be a point over here, which is negative x, y would need to be contained on the same graph. So for symmetry about the x-axis, so to check symmetry about the y-axis, we need to plug in negative x for x and see if we get the same function. So if we plug in negative x for x, we'll get negative x squared plus 2 times negative x times y minus y squared equals 4. And so again, we're going to get x squared minus 2xy minus y squared equals 4. So again, we've got this negative sign there that was a positive sign in the original function. So it is not symmetric about the y-axis. Okay, and to check symmetry about the origin, that is, if for any given xy point, we would have to have negative x, negative y would also have to be on there if it's symmetric about the origin. So for symmetry to check symmetry about the origin, plug in, we're going to do both, negative x for x and negative y for y. So we're going to do both things. So we're going to get negative x squared plus 2 times negative x times negative y minus negative y squared equals 4. And when I simplify that, I'll get x squared plus, because I have minus minus, 2xy minus y squared equals 4. And what I notice is that's the same as the function we started with. So all the signs are the same and everything. And so what that means is that it is symmetric about the origin. Okay. For the next one, I want to determine if the function is even, odd, or neither. And so what that boils down to is plugging in negative x for x. So to check even, odd, I want to plug in negative x for x and see what we get. If we get f of x back, the function is even. If all the signs change, then f of x is odd. Okay, so let's see what happens in this case. When I plug in negative x for x, f of negative x is equal to negative x cubed minus 4 times negative x plus 7. And so what I get is when I cube negative x, I get negative x times negative x times negative x. That's 3 negatives, so it stays negative. So that's negative x cubed. And then negative 4 times negative x is going to be plus 4x plus 7. And so when I look at the signs, I can see this sign changed and this sign changed, but that sign stayed the same. So it's neither even nor odd. Then it says, use the graphing capabilities of your calculator to approximate the relative minima and relative maxima of that function and round to 3 decimal places. So if I sketch a graph of this function once I plug it into my calculator, it looks something like this. So it looks like I have something like that. And so if I use my calculator to do that, I'm going to do, first we'll find a maximum. So I go to the left, and I go to the right of it. So it looks like the maximum value, so what does it say? So the maximum happens at, so the max happens at negative 0.14549, and the maximum value is 2.0758. Okay, and for the minimum, oh, I went to round to 3 decimal places. Okay, so let's see here. 145. Oh, whoops, I want to eraser. There we go, and then 3 decimal places, so I'll turn that to a 6. Okay, whoops, now it's big. Okay. So, next, let's find the min. So, calculate minimum. I'm going to go to the left of it, and then go over to the right, and it looks like my minimum happens when x is 1.145, and the minimum value here is negative 0.076. So that's the y value and the x value of the minimum. Okay, then determine the intervals on which the function in question 27 is increasing and decreasing. So it looks like it's increasing here. We always, when we talk about increasing, decreasing, we always move from left to right. So I can see the function is increasing here and decreasing on this interval. Okay, so increasing on 2 intervals. So it starts from negative infinity, and then when it reaches that maximum, the x value is negative 0.145. Union, then it starts again at this minimum, which is 1.145 for the x value, to infinity. And when we're talking about the intervals on which it's increasing, we're always talking about intervals of x values. So, so that's that. And then for decreasing, okay, we're going to go in between. So negative 0.145 to 1.145. And so we're talking about this interval of x values there. That's what we're writing down. Then it says, so the next problem. Use the piecewise defined function, which is that thing, to answer 29 and 30. Okay, so I'm going to evaluate some different points. So if I want to find h of negative 2, when I want to evaluate this, I'm going to start on the right-hand side, and I'm going to say, okay, negative 2 is less than or equal to 2, so I'm going to use this top function. So h of negative 2 is going to be negative 2 plus 3, which is 1. H of 0 is going to be, so let me erase that real quick, and let's think about this. Well, 0 is less than 2, so I'm going to use this top one. 0 plus 3, which is 0. And then h of 2, I want to see which one am I looking at. Is 2 less than or equal to 2, or is 2 greater than 2? Well, it's less than or equal to 2, right? So I'll have 2 plus 3, which is 5. Now when I get to h of 5, I'm moving on, and I am going to use the other function because 5 is greater than 2. And so h of 5, I'm going to use this function now because I'm down here. So it's going to be 5 minus 5, which is 0. And then I want to graph that function. So what I can see is it's made up of 2 linear pieces. And I can plot the points here that I've just done. So there's 2. Okay. So h of negative 2 was 1. H of 0 was 0. H of 2, oh, h of 0 is 3. Oh, what am I doing here? H of 0 is 3, not 0. Okay, there we go. Now that makes much more sense. Okay, let's see if I can fix this. Okay, now h of 0 is 3. 1, 2, 3. And h of 2 is 5. So that's here. So there's that part of the line. And then it's going to skip down to this function. And if I plugged in 2 to that bottom function, I have 2 minus 5 is negative 3. So I should have a hole here at negative 3. And then 3, 4, 5. I got 5 was 0. So my function, that function goes like that. They should look parallel to one another because they have the same slope. X minus 3, or x plus 3 and x minus 5 both have slope of 1. So they should look parallel to one another when I graph them. But there should be a filled-in hole here on the x plus 3 and an open hole here on the x minus 5 function. Okay, so we graphed it. All right, the next one says I have 2 functions for f and g, and I want to simplify. So if we do f of x, f plus g of x, that's f of x plus g of x is how that's defined. And so f of x is x squared minus 4 plus g of x is x plus 2. And if we simplify that, we'll get x squared plus x minus 2. Okay, and then if I do, this is implying multiplication, f times g of x. Oh, whoops, I switched to green there. So that gives me f of x times g of x. And so if I just multiply those two together, I'm going to get x squared minus 4 times x plus 2. And if you want, we can multiply that out. So I'm going to distribute that to each of those, and then that to each of those. So we're just distributing the x squared across the x plus 2. So I'll have x cubed plus 2x squared. And then I'll distribute the negative 4 across both. So I get negative 4x minus 8. And so then I can, that's it. I don't have any like terms. So x cubed plus 2x squared minus 4x minus 8. And if I do g minus f of x, that's defined to be g of x minus f of x. And so I can do that subtraction there. So I'll get x squared minus 4 minus x minus 2. X plus 2. Sorry, there we go. And so then I get, if I distribute this negative across both of those, I'm going to get x squared minus 4 minus x minus 2. So that's x squared minus x minus 6. Okay, and then the last one, g divided by f of x is defined to be g of x divided by f of x. So I will get my g of x again is x squared minus 4, and my f we're doing g divided by f. Whoops, I did it the opposite way. Let's do g divided by f. I did f divided by g. Well, let's do g divided by f because that's what it asked us to do. Okay, so g is x plus 2, and f is x squared minus 4. One thing you might notice is that x plus 2, x squared minus 4 simplifies to x plus 2, x minus 2. And so you might be tempted to cross these out and say that they're equal. But what happens is that they're only equal if we exclude the point where the function is undefined. So I'm going to not cancel those, but I just wanted to point out that we do have x plus 2 over x plus 2, which we could cancel, but the functions are going to be equal everywhere except for the one point where it's undefined, which happens at x equal negative 2. Okay, the next one. I have this function, and I want to find this difference quotient for the function. So for the first part, I'm going to plug in x plus h in place of x, and then I'm going to plug in just the function f of x, and then I'm going to divide all that by h. So I'm going to go over here because we're going to need some space for this one. So we'll do 3x plus h squared minus 2 times x plus h plus 7. So that's what I get when I plug in x plus h for x. So that's that first part. Then I'm going to do minus, and then I'm going to do just f of x, and that's just the same as the function that we have here. So that's 3x squared minus 2x plus 7. So that's that green part there. Yeah, and all of that is divided by h. So let's see if we can simplify that a little bit. So when I multiply that x plus h times x plus h, I'll get 3x squared plus 2xh plus h squared. And then minus, and then I'll go ahead and distribute that 2 into both of those. 2 minus 2h, 2x minus 2h, and then plus 7. And then I can distribute this minus into everything there. And so I'll get minus 3x squared plus 2x minus 7. So let's see, all of that's going to be over h. So let's keep multiplying out on the top. So I'll have, I'm going to go ahead and distribute that 3 across all of those. So I'll have 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 7 minus 3x squared plus 2x minus 7. And so I think that is all. So now we're going to look for common factors, things that we see. So I see the plus 7 minus 7, so that's going to add to 0. I see a plus 3x squared minus 3x squared. I see a minus 2x and a plus 2x. And it seems like that's all that's going to, and all of that's divided by h again. So I'll have 6xh plus 3h squared minus 2h. All of that's divided by h. What I might notice is that these have a common factor. They all contain an h in them. So what I'm going to do is factor that h out of all of those. So I'll have h times, when I factored the h out of this first term, all that's left is 6x. When I pulled an h out of this 3h squared, I have a 3h left. And when I pull an h out of this negative 2h, I just have negative 2. And then all of that's divided by h. And now I have h divided by h, and that divides to make 1. And so I'm left with 6x plus 3h minus 2. And that's that's as simple as we're going to get there. Okay, so next I have g and f, and I want to compose them. So if I do f composed with g of x, that's defined to be f of g of x. So in other words, I want to do f of, and what is g of x? 4x minus 7. So in my function f, everywhere I see an x, I want to plug in 4x minus 7. Okay, and so then I'm going to compute that. So I'm going to square this 4x minus 7, so I'll have 2 times. When I square the 4x, I get 16x squared. My middle terms are going to be 7 times 4, 28 times 2 is 56. So minus 56x, and then plus 7 squared is 49. And then when I distribute this 3 into here, I'll have 12x minus 21 minus 5. Okay, so let's distribute the 2 across here, and then we'll see if we can get some like factors. Okay, so 2 times 16 is 32. X squared minus 56 times 2 is 112x, and then 49 times 2 is 98, plus 12x minus 21 minus 5, so minus 26. All right, so we should have some common terms here. So 112, negative 112 plus 12, so we have 32x squared minus 100x, and then 98 minus 26 is 72. Okay. And so that is f composed with g of x. 32x squared minus 100x plus 72. Okay. And then I want to do g composed with f of negative 3. So the nice thing about this one is since it gave me a value for x, I don't have to do quite as much work in general. So if I want to do g composed with f of negative 3, oh, whoops, I had an extra parentheses there. Let's see if I can get rid of that guy. Okay. Okay, so that's going to be g of f of negative 3. And so what I can do is I can plug negative 3 into my function f first. So what is negative 3 plugged into f? So I'll have 2 times negative 3 squared plus 3 times negative 3 minus 5. And so if I do that, that's g of, let's see, negative 3 squared is 9 times 2 is 18. 3 minus 3 is, 3 times negative 3 is negative 9, and then minus 5. So 18 minus 9 minus 5 is 4, right? So that's g of 4. So when I plug the negative 3 into f, I get 4. Then I'm going to plug the 4 into g, and I'm going to get, well, g says 4 times x minus 7. So 4 times 4 minus 7 is, 4 times 4 is 16, minus 7 is 9. So this is equal to 9. Okay, and so the next one says, I'm going to erase some things here so you can see what we're doing. All right, and so it says, given h of x is x cubed plus 5 over x cubed minus 4, find two functions f and g such that h of x is f composed with g. So when I'm looking at this, the first thing I'm seeing is I'm seeing this x cubed appear multiple times. And so my first thought is maybe my inside function is going to be an x cubed. So I was thinking I'd let g of x equal x cubed. And then the x cubed is being plugged into what function? I could think of that as just an x plus 5 over x minus 4. And so if I plug that x cubed in for x in both of these places, if I take this x cubed and I plug it into both of those, then I'll get the function that I started with, x cubed plus 5 over x cubed minus 4. And so that's what I think. I think that if I let f be x plus 5 over x minus 4 and g be x cubed, then if I compute f of g of x, that's going to be f of x cubed, and that's going to be x cubed plus 5 over x cubed minus 4, which is what we're trying to